This is another easy question on Gauss law from JEE 2020. And it says that a circular disk of radius r carries certain charge density as a function of the radial distance. So if this is the disk that the question is talking about and it has radius r, then add a certain radius small r. It has a specific surface charge density, where sigma naught is a constant and r is the distance from the center of the disk. Electric flux through a large spherical surface that encloses the charged disk completely is phi naught. Electric flux through another spherical surface of radius r by 4 and concentric with the disk is phi. Then the ratio of phi naught upon phi is. So if I draw the disk a bit better this time, so something like this, and it has a radius r, and you have a Gaussian surface, which is a sphere, and that sphere has a radius of r by 4, so above and below it, and another Gaussian surface which is quite large enough that it fits in this disk completely. And so phi naught, the flux through the bigger surface, well, that is equal to the total charge enclosed, total on the disk, since it's all enclosed, and by Gauss's law, the enclosed charge will be all charge in the disk, total on disk, divided by epsilon naught. And if you talk about this phi, do that in a different color, the phi is equal to q enclosed in a radius of r by 4, and that 2 divided by E naught. So the total charge, if you take an element at radial distance r, which has a thickness dr, then this circular element, has a net charge of sigma r times 2 pi r dr, and then you integrate it. So, and if you want to figure out the total charge, you integrate it from 0 to capital R. So this is from 0 to capital R, sigma naught comes out, and you also have 2 pi coming out. So let me just write that together. 2 pi sigma naught from 0 to r, 1 minus r by r dr. So many r's here, but this is equal to 2 pi sigma naught, and this will be r squared by 2 minus r cubed by 3r from 0 to r, and that is equal to 2 pi sigma naught, and if you do the math here, this will come out to be r squared upon 6, so this will be pi sigma naught r squared upon 3. If you want to figure out this red charge till q by 4, you just change the limits till from 0 to r by 4. So this will be 2 pi sigma naught r squared by 2 minus r cubed by 3r, and you have from 0 to r by 4. And so this will be 2 pi sigma naught, and I'll have to do the math here myself. At 0, this entire thing is just 0. At r by 4, this will be r squared over 32 minus r squared over, well, it will be 64 times 3. 64 times 3, well, that comes out to be, this will be 64 times 3. So this will come out to be 192. And now, we have to just do a bit of math here, just a bit of arithmetic. This will be equal to 2 pi sigma naught 160 r squared divided by 32 times 192. And if you want to figure out what sigma naught upon phi naught upon phi is, pardon me if I've been using sigma all the time, this is just equal to, well, the charge on total divided by the red charge, so QR by 4, and since these epsilon naughts anyways cancel out, so you're left with 1 by 3 here. Let me just erase this portion. 1 by 3, and here you have 2 times 160, and you have 32 times 192. Oops, I spilled out of the boundary. Anyways, this will be equal to, you can cancel this 3, and that will give you 64 times 32. 64 times 32 divided by 2 times 160. And we know that this is equal to 320, so this will cancel out, and you have 64 divided by 10, that is equal to 6.4. So the ratio is going to be 6.4.